All right, so here's my oscillation problem. First thing I see, mass is bouncing slowly up and down on the spring. With each bounce, the vertical displacement changes by 14.2 centimeters over 0.675 seconds. At t equals 0, it's at its maximum displacement of 17.3. All right, so the furthest away it is, it says maximum displacement at 17.3. All right, so let's make sense of that for a second. If I'm looking at this chart here, there's some equilibrium spot, there's some bottom, okay? Right now, you are at 17.3 centimeters above the ground. All right, it's at its max displacement. This thing's gonna go all the way down, bounce, and then go back up. All right, so with each bounce, it changes 14.3. So, 14.2 centimeters. So it's gonna come all the way down. It's not gonna come down to 0. It's gonna come down 14.2 centimeters. So if you come down 14.2 centimeters, obviously not 0, how far down do you go? To what number? So 17.3, so take away your 14.2, and now you're at 3.1 centimeters above your ground. Okay? And then eventually, so it bounces to here, so it gets to this spot here, and then it bounces back up. So far, so good? And in that, and one more piece here, is in that first bounce, it takes 0.65 seconds to make that. So at that first bounce, I'm at t equals 0.675 seconds. So I'm going to give you another little sketch. I'm at maximum equilibrium. I come down. I'm at my equilibrium. Now I'm at the lowest. Then I get back to my equilibrium. And then eventually back to my 17.2 centimeters off the ground. 17.3 centimeters off the ground, okay? So 17.3 is where I start. Then it goes, and what happens is in that first bounce from here to here, this happens in 0.0675 seconds. Is that a full period? Is it 0.675 seconds a full period?
No.
It's got to go back to its original. So I got to go back to my maximum height here of 17 point, right, this was 17.3. So how long before I go back? How much more time? If I took half the time of 6.675, it's going to take the same exact time to go back. So the full time to oscillate from maximum height of 17.3, come back, bounce, and go back to back to 17.3 is going to be what? 1.35 seconds. So that 1.35 seconds represents my period. So graphically, I'm going to take this, so I got my period is equal to 1.35 seconds. I got that. My max is 17.3, and then I'm just going to borrow this for a second. Okay, so here's 17.3. We said this was 3.1, and this is doing this over 1.35 seconds. We could easily get the other times now, right? What's a quarter of 1.35 seconds, right? Because each one of these is going to be a quarter of, right? So this next one's a quarter of 1.35. So it's a quarter of 1.35.
0.34.
0. Give it to me. Give me all the decimals.
3375.
3375. Now keep adding 3375. So this one's going to be 0.675. Add 0.3375 to this one again. So we're going to keep adding 1, 2. What's 0.675 plus 0.3375? 1.0125. Add it again one more time, and you should get back to your 1.35. Okay? So once you know your period, just take that period, divide by 4, and that'll be your first interval, your second interval, third interval, and you should get back to your full period. Now at time 0, I'm at 17.3. Awesome. My maximum goes to 17.3. The minimum goes to 3.1. What's missing? What else do I need here? Your midline. What's my midline? So what's 17.3 plus 3.1 divided by 2? 10.2. Before I agree to that 10.2, just very quickly, what's 17.3 minus 10.2? So what's the, let's just test this. This is your amplitude. So what are you getting? 7.1?
Yeah.
And what's 10.2 minus 3.1?
Simple.
Okay. Make sure that matches, right? You gotta be in the middle there. So my amplitude is 7.1. So I got amp 7.1. Midline 10.2. Period 1.35. Okay, if I got my period at 1.35, then my B value is what? What's my B value? 2 pi over 1.35, which looks a little funky. All right, if you have that, if you have a decimal in your denominator, how many decimal places? 2, so move it over twice. If I do it to my numerator and my denominator, then I got to do it to my numerator. So this is really 200 pi over 135. And if you make a fraction into your calculator and plug that in, 200 over 135, it'll simplify for you. What do you get when you simplify 200 over 135? 40 over 27. There's my B value. My midline, I'm going to just draw that in. At 0.676 seconds, I'm at 3.1. Where am I at 0.3375 seconds?
The midline.
Midline, 10.2. So right, you got to cross the midline. So I'm crossing the midline. I get to my bottom point at 0.67 seconds. 1.0125, where am I at again?
Midline.
Back to my midline. 1.35 seconds, my full rotation, my full period, and back to 17.3. So there's my graph, and now go on forever and ever and ever. Y equals amplitude, 7.1. Sine or cosine?
Cosine.
Does not start in the midline, right? Starts above the midline, so cosine, positive or negative?
Positive.
Positive cosine because it starts above the midline. Awesome. My B value, 40 pi over 27 times t. Any phase shift? No phase shift. Plus, and what's your midline? 10.2. Now you have your full equation, and you can answer any other question that goes with it. Where are you at 5 seconds? This is going to oscillate continuously for however long until you stop it. Yep. Where are you after 5 seconds? So this is, I'm going to call this h of t instead of y. Oop. So h of t equals h of 5 equals 7.1 cosine 40 pi over 27 times 5 seconds plus 10.2. You can get a rough idea, right? If you follow that curve all the way around, so 1.35, 2.7 brings you back, right? What do you got?
Like 8 meters.
8.16,
1.6.
so about 8.16 meters, sure. If you put 8.16, 8.2, sure. And the last one, when will it be exactly 10? So when's it going to be exactly 10? So here's 10.2, right? So exactly 10 is going to be somewhere around there. Right, that coordinate is something, comma, 10. And I'm looking for the x value here. Algebraically, you could do this. Okay, so my height is going to be 10. So 1 to 10 equals 7.1 cosine 40 pi over 27 t plus 10.2. We're going to do this very soon, okay? My goal here is to get t. To get t by itself. All right, so in steps, I'm going to subtract 10.2. So 10 minus 10.2. Then I'm going to divide by 7.1. And that's going to give me cosine of 40 pi over 27 t. And then since the t is buried inside the argument of the cosine, I got to get rid of cosine. Right? Everything has an inverse. So the inverse of cosine, I'm going to move this over a little bit. Looks like this. I'm going to take the inverse of cosine. And if I take the inverse of one side, then I got to take the inverse of another side. And you'll see that button on your calculator, right? Cosine to, looks like cosine to negative 1 power. It's not. It's the inverse. And the cosine inverse and the cosine will cancel each other out. So you're left with cosine, the inverse cosine of 10 minus 10.2, whatever that is, divided by 7.1 equals 40 pi over 27 times t. And, yep.
Can you exactly remind me why we got 40 pi over 27?
So when we recognized the period was 1 minute 35 seconds, your b value comes from your period, right? So b is going to equal 2 pi over your period. So I plugged a period in here. And then I simplify 2 pi over 1.35 into this, and then into this. All right, so I just moved my decimal. So you can't have a decimal in a fraction, so I just moved that over and got that. All right, I'll finish that up and I'll explain this one more time. And then the last piece here, I don't want 40 pi over 27 in front of t. How do you get rid of dividing by 27? Multiply by 27. How do you get rid of multiplying by 40 pi? Divide by 40 pi. T equals all this. All right, and we'll start doing that a little bit more as we move forward. Any questions?